Okay, gang, so let me fix that. So we're working on section 2.3, I believe. Yep. And we're going to keep looking at how to handle indeterminate forms. So if you notice on this problem, if you let x be 0, you're going to get 1/4 minus 1/4 over 0 or 0 over 0. So this case here, if you do the plug and chug, you get an indeterminate form. It doesn't work out on the first run through because you get the indeterminate form. So what do you think you might do in this case? Okay, hopefully you're thinking LCD. So the LCD for this one, for the numerator is 4x plus 4. Right, and if I balance it out, so I would multiply up down by a 4 to this side, and I would multiply up down by an x plus 4 to this side, and now they both have the same denominator, so I can combine the numerator. So 1 times 4 is 4. Minus, you're going to distribute this minus 1 in here, so this is going to become minus x, and then minus 1 times 4 is minus 4 all over the LCD, which is 4x plus 4 all over x. Okay, so because I got the LCD here, I was combining the numerator. Now I'm going to keep going with this, so if I combine like terms, the 4 and the minus 4 go away. Now I'll write this out the long way because it's a little easier for some people to see it. So this is basically a complex fraction. So it's going to be the top fraction divided by the bottom fraction. And if I didn't say that in the beginning, this is what you would call a complex fraction. A complex fraction is when you have fractions inside of fractions. It's like if you've ever seen that movie Inception, right? It's a reality inside a reality. So here's the bigger fraction. This is the big fraction. And then there's the little fractions. So a complex fraction, this is called a complex fractions when you have fractions inside of fractions. Alright, so I'm just going to solve this out the long way. If you know how to do it a different way, that's fine. It's just a little easier for most students to see it this way. So it's a top fraction divided by x. Notice I'm still carrying the limit because I haven't used it yet. Oh, hold on. I changed that. Alright, now I'm going to change this to multiplication. I'm going to flip this side. Okay, and as you can see, what happens here is that the x's are going to reduce. Alright, so now that I've simplified the complex fraction, I'm going to go ahead and plug in now the limit. So I'm going to put the 0 in now. So you're basically going to have negative 1 over 4 times 4 in the bottom, which is going to be negative 1 over 16. Okay? And that's the final answer. That's the limit. So remember, don't drop the limit until you use it. So just as a very brief recap, if you're taking the limit of a complex fraction and you're getting an indeterminate form, the concept is to use the LCD to collapse the complex fraction into a simpler fraction and then take the limit of that. Okay, gang, we're going to hang out longer in 2.3. I'll catch you in another video. Bye-bye.